This is my video lab report for Lab 1, Constant Velocity. In this lab, I analyzed the motion of an object moving at a constant velocity using the program Tracker, and compared these experimental observations with a computational model using VPython. My objective for this lab was to compare these two models, and use them to assess motion with no net force. This lab explored Newton's first law of motion and the momentum principle when the net force is zero, as well as the kinematic relationships between position, velocity, and time. Overall, in this lab, I found that the computational model did closely match my observed motion, supporting the idea that when the net force is zero, an object continues moving at a constant velocity. For my experiment, I recorded this video of my object moving in a straight line on a frictionless track. Then, I used Tracker to mark the object's position at different steps of time. I set the axes, as seen in the magenta-colored lines, so that the x direction was the direction that the cart would move along the track. And I also set the scale using the blue line there, the calibration stick, which I aligned against the measuring side of the track. The system I focused on was the cart itself, and the surroundings included the surface that it moved across, as well as the air around it. To the right you can see Tracker's output. Looking at the x position versus time, there is a linear graph as well as a data table that I used for my data analysis. I set the origin to be the starting position of the object when I started tracking its motion, so its initial position would be at that origin. The initial velocity could be approximated by taking the first few positions and dividing that by the interval of time. By default, Tracker uses 0.033 seconds as its steps of time. Now onto the computational model with VPython. Using the provided starter code, I set the net force to be zero so that the velocity would remain constant. This meant that the only thing that would change was the position. As such, I set the position to update using the position update formula, which can be seen in the snippet of code above. To the right is the output of the program, which showed the object moving and its motion being represented by the linear graph. The data generated by the program would be used to compare with my observational data from the experiment itself. Here, I've plotted both the Tracker data and the VPython output on the same position versus time graph. As you can see, the two lines match very closely, showing that the measured velocity agrees with the predictive computational model. Let's discuss what this means. The experiment confirmed that the momentum principle predicts motion well when the net force is zero. That is to say, without any force, momentum, and therefore velocity, is constant. This reflects Newton's first law of motion. Of course, there are potential sources of error for this lab. The way the video was recorded may have been at a difficult angle such that Tracker could not properly calculate the object's motion. Plus, my clicks might not have been perfectly precise with where the object's position was marked at each time step. The axes or calibration stick could have been improperly set up as well. Now for the what-if questions. Had I flipped the axes and taken the negative x direction as opposed to the positive x, the slope of the line would change sign, so the velocity would look negative instead of positive, but the overall physical result would be the same beyond that. Regarding the net force, just because my computational model sets the net force equal to zero doesn't mean that there are no forces that exist. There could be plenty of pushes and pulls canceling each other out, or very small forces that I did not account for. Just from the motion alone in the experiment, you can't exactly tell just how many forces are acting, only that the sum is approximately zero. There could be frictional forces related to the surface and any imperfection in the surface, as well as things even like air resistance. In conclusion, my experimental observations matched my computational model closely, supporting Newton's first law that an object with no net force moves with a constant velocity. Note that, to apply this principle to my experiment, I had to assume that my setup minimized friction and drag so that the net force would approximate to zero.